Today we are going to do binomial theorem. Suppose you are asked to find the expansion of a plus x to the power n, where n is a natural number. Suppose you are asked to find the expansion of a plus x to the power n, where n is a natural number. So it is equivalent to multiplying a plus x with itself n times. So if we choose a from every bracket, we will get a to the power n, or if we choose x from one bracket and a from the remaining, we will get this. If we choose x from two brackets and a from the remaining, we will get this. And if we proceed in this manner, then finally we will get x to the power n. So this is known as binomial expansion of a plus x whole to the power n. For example, suppose you want to find the binomial expansion of a plus x whole to the power 4. So a to the power 4 plus 4c1 a to the power 4 minus 1x plus 4c2 a to the power 4 minus 2x square plus 4c3 a to the power 4 minus 3 into x cube plus x to the power 4. So the answer will be a to the power 4 plus 4a cube x plus 6a square x square plus a to the x to the power 4. So this is the binomial expansion of a plus x whole to the power 4. Now, suppose you are given an application of binomial theorem, like for example, you have to prove that 2 to the power 3n minus 7n minus 1 is divisible by 49. So we can write 2 to the power 3n as 1 plus 7 whole to the power n minus 7n minus 1. So we are getting 1 plus nc1 into 7 plus nc2 into 7 square, and finally minus 7n minus 1. So if you take 7 square common, you will get nc2 and so on. So you can clearly see that this is a multiple of 49. So this is an example of how to apply binomial theorem. Now, in the binomial theorem, there is a formula for general term. Suppose we are finding binomial expansion of a plus x to the power n. So the general term will be NCR a to the power n minus r into x to the power r. This is the formula to find the general term. So, suppose if we are told to find the fourth term from the end of this expansion, suppose. So what we will do is we will rewrite the expansion like this. And once we have written it like this, we basically need to find the fourth term from the beginning. So this is minus 2 by x square to the power 6 into x cube by 2 all to the power 3. So this is what we will get. So after simplification, it is coming 672 by x cube. This is the binomial expansion. We can also use it to find the term independent of x. For example, suppose you have x minus 1 by x to the power 14. So the general term will be 14cr x to the power 14 minus r minus 1 by x to the power r. So basically, to find the term independent of x, we need to equate 14 minus 2r to 0. So r will be 7. So the term independent of x will be 14c7 minus 1 to the power 7, which is coming as minus 3432. Now, in the expansion a plus x to the power n, if n is odd, then in that case there will be two middle terms. The n plus 1 by 2th term and the n plus 3 by 2th term. And if n is even, then the middle term will be n by 2 plus 1th term. So this is the formula to find the middle term. So for example, if we have x square minus 1 by x to the power 6, so you can see that the power is 6. So the middle term is the 6 plus 1 by 2th term. which means it will be the fourth term. So for the fourth term, this is the calculation. So that means the middle term answer is coming minus 20x cube. So this is how we can find the middle term or the middle terms of a binomial expansion. Suppose one binomial is there, 1 plus x to the power 18, and you are told that the coefficient of r plus the coefficient of 2r plus 4th term and coefficient of r minus 2th term both are same. So we can say like this, that 18c 2r plus 3 is equal to 18c r minus 3. So according to the concept of combinations, the sum of the subscripts should be equal to the superscript. So r should be equal to 6. So in this particular question, the answer will be r equal to 6. Now, binomial theorem does not mean that the index has to be a natural number. It can be any rational number, positive or negative. So, the binomial theorem for any index is as follows. Suppose 1 plus x to the power n. So 1 plus nx plus n into n minus 1 by 2 factorial x square and so on. So this is the binomial theorem for any index, that means any power. So for example, if you have a binomial like this, 1 minus 3x to the power minus 1 by 3, in that case the expansion will be like this. So 1 plus nx plus n into n minus 1 by 2 factorial x square and so on. So this will be the binomial for any index. One important thing, in binomial any index, the value of x must be a proper fraction. That means mod x should be less than 1. This is absolutely essential. Now, suppose there is one binomial expansion like this. One plus x whole to the power 3 by 4 plus root over 1 plus 5x whole thing by 1 minus x whole square. So if you expand this, up to 3 terms, this is what you will get. Similarly, you expand the other one up to 3 terms, divided by 1 minus x whole square. So these will be the terms. Divided by 1 minus x whole square. So if you total 3x by 4 plus 5x by 2, it's coming to 13x by 8. And if you total these two terms, it's coming 103x square by 32. 1 minus x to the power 2, which is in the denominator, if you bring it to the numerator, you will get this. Now if you multiply these two, 2 into 1 is 2, then 13x by 8 plus 4x. So that is coming to 45x by 8 and 26x square by 8 plus 3x square minus 103x square by 32. So this is coming 104 plus 96 minus 103 x square. So this is the way to evaluate this kind of a binomial. So 1 plus 3 by 4 plus 3 into 5 by 4 into 8, etc. Suppose this is a binomial expansion. So this will be 1 plus x whole to the power n. So if you compare on both sides, nx will be 3 by 4 so n into n minus 1 into x square by 2. So this is what we will get. So ultimately when we solve for x, x is coming to minus half. If you go back here and put the value of x, then it's coming to minus 3 by 2. So this is how we can convert an infinite series into a binomial. Now we come to the next topic, binomial coefficients. Suppose 1 plus x whole to the power n suppose we are expanding it, so it's coming c0 plus c1x plus c2x square and so on. So if you put x equal to 1, you will get this. Two to the power n is c0 plus c1 plus c2 up to cn. If you put x equal to minus 1, then you will get this series c0 minus c1 plus c2 etc. If you add number 1 and 2, this is 1, this is 2. Suppose you add both of them, then you will get this. So 2 to the power n minus 1 is c0 plus c2 plus c4. So you can call this as number 3. Now suppose you subtract 1 and 2. Then you will get this. So 2 to the power n minus 1 will be c1 plus c3 plus c5 etc. So you can call this as number 4. So these are the first 4 results, 1, 2, 3, 4 of binomial coefficients. Suppose you want to find the value of a series like this, c1 plus 2c2 plus 3c3 up to ncn. Suppose you want to find the value of this series. So we can write all the terms like this. So after taking n common from every numerator, we get a series like this. That can be further written like this: n into n minus 1 C0 plus n minus 1 C1 and so on. You know that according to the first formula of binomial coefficients, this term inside the bracket is 2 to the power n minus 1. So we are getting the fifth result of binomial coefficients, C1 plus 2, C2 plus 3, C3, etc. is n into 2 to the power n minus 1. Suppose we want to find the sum of a series like this. So we proceed by writing everything in the binomial expansion. So we will get one by n plus 1 into n plus 1 factorial by 1 factorial into n factorial plus n plus 1 factorial by 2 factorial into n minus 1 factorial, which will finally give n plus 1 C1 plus n plus 1 C2, which is 2 to the power n plus 1 minus 1. So this is result number 6 of binomial coefficients. Suppose we have to find the sum of a series like this: C0 C1 plus C1 C2 plus C2 C3 up to Cn minus 1 Cn. So we will begin by first writing one identity, 1 plus x whole to the power n into 1 plus 1 by x whole to the power n is equal to 1 plus x whole to the power 2n by x to the power n. Okay, now after writing this identity, we will get C0 plus C1x up to Cn x to the power n. C0 plus C1 by x plus C2 by x square is Cn by x to the power n. So if we expand 1 plus x to the power n, this is the expansion. 1 plus 1 by x to the power n, this is the expansion. And on the right hand side we have this ratio. Now if you look carefully, you will see that C0, C1 plus C1, C2, etc. This is the coefficient of 1 by x in the LHS, and that should be equal to coefficient of 1 by x in the RHS which is this. So that is coming to 2n Cn minus 1. Which after expansion is coming to this. So the way to solve this problem is by first writing the identity and then solving it. Suppose we need to find a series such as this one. Suppose we need to find the sum of such a series. So we will begin by writing the identity 1 plus x to the power n into 1 plus x to the power n is equal to 1 plus x whole to the power 2n. Now if you look carefully, the calculation which is required is basically the coefficient of x to the power n in the LHS, and that will be equal to coefficient of x to the power n in the RHS. So this will be the answer. So this is the topic binomial coefficients, and with that we come to an end of this session of binomial theorem.